Okay, everybody, welcome back. We're going to get started. This is the second to the last lecture, and as I was just discussing with some of the students before I started the video here, next week I'm going to cover EE, Enterprise Edition Programming. So I'll do an overview, which is going to lead into the next class, which is going to be called Java EE Programming, that I'm teaching next quarter, or semester, I should say, in January. So it'll be sort of an introduction to that class, a little overview of all of the EE stuff and where to find the resources and stuff like that. So this is really, the EE course is a continuation of this course. So I'd call it maybe Advanced Java Programming or Enterprise Edition Programming. But in any case, we're still in the beginning Java programming, the object-oriented programming. And we're looking at lecture number 10 today on documentation, garbage collection, and nested classes and interfaces. None of these concepts have anything to do with each other. They just happen to appear in the same slide set. There are three three concepts that any Java programmer should know about. But they have nothing to do with each other. I just tossed them in here. It's kind of like one of our final lectures for this course. And this will be the last lecture, actually, of the new information. After this lecture, I pretty much covered everything. Interfaces, abstract classes, inheritance, reuse, all of the, I've covered everything. So these three topics are what we have left. And every programmer's favorite thing to do is to document source code, right? We all love to document source code. So Java actually has a built-in utility to do this for us, and it is called the Java Docs. And the documentation is done semi-automatically. I wouldn't say completely automatic, but it's semi-automatic. You still have to put stuff in the code, but what ends up happening is you run a Java Doc tool, and it goes through the code and it parses out the little pieces of information you left in the code. And it creates the documentation for you. It's kind of like the final summary, and it'll go through all of the different files in the package or in your application, and it'll automatically create an HTML compatible Java Doc sort of resource for you. But the problem is you have to learn the syntax for documenting internally. They call it internal documentation. For internally documenting your source code, you have to actually do it in a certain way in order to have things tagged and categorized correctly for when the Java docs actually get created. So it's a toss-up as to whether or not it's worth it. There's some people who swear by Java docs, use it all the time. There's some who have never actually used it at all. And then we have some tools such as Eclipse that has a Java Doc feature already implemented into the interface, which will create it for you automatically. It'll actually run the Java Doc for you. It doesn't actually put your comments in. You actually have to write the stuff in the code to comment it. And that's the purpose of today's lecture is to kind of look at how that's done. And you don't have to do that for any of your programming assignments for this course. So the standard API is showing an HTML output, and it is at this location right here. It's generated from Java Docs.comments. Actually, all of that documentation, and I personally don't like it. If you go on the internet and search on some Java library of some sort, you're bound to come up with the documentation, and it's going to be in HTML format, and it's going to be in what I call minimal, not very much help, not very much support kind of format. I'm sure you've all seen it. Looks like a little hierarchy. You click on it, it opens up. You can see where this class was inherited from, and it's like a blue and white. It used to be blue and white, and it looked good, but I personally didn't find it actually contained very much information. It doesn't have any examples, or it doesn't contain very much wordage. It just says this does this, this does that, and you're like, okay, great. Unfortunately, I should say fortunately, all that stuff was created automatically. Unfortunately, if you don't put the comments in the code, the comments don't end up in the Java docs either. So it's kind of like you have to write it somewhere, whether you write it in your own documentation or whether you write it in the source code. So you can't really avoid documenting software, which is the long story short. Even the automated tools don't do it for you. So documented comments are special comments that are in the source code that are delimited by this particular delimiter. It looks like comments, right? So they're actually read like comments. So the JDK tool is called JavaDoc. It generates the HTML documentation from the documentation comments in the source code. So JavaDoc utility extracts information for the following items. Okay, so it'll list out the public classes and the interfaces. It'll list out the public and protected methods, the public and protected fields, as well as packages that might be contained. So here's a sample comment that you put into source code. So the comment itself, the doc comments start out with 3 characters, this one and 2 of the asterisks, and continue until we get the ending tag. If you leave out one, we're looking at a regular old comment. So you put the 2 asterisks in here. You can see that. Actually, I can make this a little bigger. Oh, that's really big. You can see the 2 asterisks here. This little box extended, made it too big. Do what the invoker intends. Intention is defined by an analysis of past behavior as described by the ISO, blah, 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 blah. Okay, well, that makes a lot of sense to me. No, it makes absolutely no sense to me. However, that's the comment as an example that would go into the source code right before this method here to dewim, which throws an internet unknown exception. So the leading asterisk characters on each one of the lines, which is kind of different than what you get in commenting. So in regular comments, you get a backslash and an asterisk, and then you have everything. And then you have the closing asterisk and the backslash. Here you have an asterisk on each one of the lines. So precedes the white spaces. They're ignored. The white spaces are ignored. So the first sentence of the comment is the summary of the identifier. So that's going to be the summary of the identifier itself. And these actually end up as different parts in the JavaDoc. And then you can use most of the HTML tags in the text format that provide cross-reference links to other documentation, and we'll see that in a few minutes. So only doc comments that immediately precede a class or an interface method or a field are processed. So you can put doc comments anywhere you want. Only ones that immediately precede the class or interface methods or fields. This is an example immediately preceding this method here. We have this comment. This one's going to be used. If we put it somewhere else, it's not going to show up anywhere. It'll show up in your source code, but it's not going to show up anywhere in the JavaDocs. So, which is kind of interesting, because it's all outlined by the methods, the classes, the methods, the fields, all of the relevant parts of the source code in terms of what somebody considered relevant. If no doc comment is given for an inherit method, the method inherited by the doc comment is from its super type. So from the super type comment will be used for that. And if the method inherits doc comments from both of the superclass and the super interface, the interface comments are going to be used instead of the class. So let's take a look at some tags. As I mentioned before, you can put tags in the code. The tags tell the JavaDocs where to categorize the individual item, what to call the item. So it's like a label that you're sticking on the item so that when you generate the JavaDoc, it'll show up in a certain spot. So it looks good. The @ symbol is used for all of the tags. So @C creates a cross-reference link to another JavaDoc documentation. So it's used to a see also, so see also section at the end of the documentation. So qualify the identifier sufficiently. Which means specify the class or the interface members by using this hash symbol before the member name. If the method is overloaded, then list its parameters. So we have the hash symbol get name, which is going to be a method. And it's not overloaded because we didn't put any parameters in here. Here we have some parameters in here where we're overloading something for the host name. Specify the classes and the interfaces with their simple names. If a class interface is from another package, specify the package name. So we have a com.hostname.attribute, including the package name. And then we can actually put an hrefs in here into a spec, as an example, an HTML document. So you can also use a label, and the label after the entity reference. Here's the label here, names. So the label will be actual text that's displayed instead of get name. attribute, there's going to be a names. It's going to be called names. So the attribute is going to be called names for a get name.
What does that mean exactly? Like, let's see, attribute means you could look for another.
It's providing you a kind of a, at the end of the Java docs, there's some notes at the end that says, you know, see this for more information, see that, see.
So it says attribute, ITTR means something else.
Yeah, this is going to be a, you know, also see get name method from another Java doc. It's kind of a cross-reference, you want to call it that, from this document to another document. If you click on this, it'll take you to the other document. It's all click related, actually, and it's all produced in an HTML format, so it's clickable links. So doing this would be names. You know, if you click on names as a label, it'll take you to get names. Get names will be inside, and these are just examples. We hadn't specified what package this is in. These are all separate. Don't be confused that this would go together. These are all separate lines that would happen in totally different pieces of source code because, you know, they might be in a different package or they might have different methods. So this is an attribute, that's a method. You know, they're just independent examples of how you can word it. And here's another independent example here in terms of calling it names. But this would be at the end of the documentation. So it's really not even part of the docs. It's just something you're putting in at the end. Actually, it's put in automatically. So here's some more tags. We have the link tag, similar to the C, but it embeds a cross-reference in the text of your comments. It actually creates the link for you. The C, just using a C is not going to create a clickable link. It's just going to say also C, you know, get name. And you know, you'll be able to go and see that theoretically.
Go to the get name link tag.
Yeah, you can include the link, or you can use a link, which is similar, but you put the link in there, and it takes you to the link. So it creates the link for you. So the syntax would be at link package.class member, and then you know, we would essentially be able to click on that and go to it. So the identifier specification follows the same requirement for the C. So as an example, changes the value, it returns by call to, it'll go to get value if it's for get value. We also have the at param, which is documents a single parameter of a method. So the parameters that are associated with method calls, we could document it to give us a little bit more information about what that parameter is supposed to be. You know, saying that it's a string doesn't really tell us very much. If we say first name or last name, or first and last name, it might be a little bit more informative. So if you use the param tag, you should have one of each parameter of the method. So param, parameter name, and then the description. So as an example parameter, max, this is the parameter max, and the maximum number of words to be read, which would show up, and you would put this right before the method call, and the param would, you know, when you looked for the help on the param and for the item max, it would give us this. So each one of the parameters would have its own statement that would identify what the parameter was about. We also have one for the return, which documents the return value of the method as well. Imagine just every piece of that particular method can be documented. The parameters, the method itself, the return value, what that method overloaded, perhaps, some information about the previous method that was an inherited class or something. So the return, as an example, you would put in, you know, at return, the number of words actually read is what's being returned. Maybe that's an integer value or something. Throws, well, that one's kind of easy, actually. The throws is going to, and the exception, documents an exception thrown by the method. So if your method's going to throw or catch an exception. So if you use the throws tag, you should have one of each type of exception the method throws. So as an example, throws null pointer exception. The name is, in the code, well, so it would be a tag for the code, null, which means if you essentially, you're taking that the name that was passed was null, so basically created a null pointer exception. Depreciation, if something is depreciated, which means it's from a previous Java API, or JDK, I should say, and it's since been, it's outdated now, or we're still using it because we need to support some legacy code or something. So it marks that an identifier should no longer be used, perhaps. It should suggest a replacement identifier. We see depreciated comments when we see the output of the source code. As an example, when we run Java C, when we run Java, and we see the output that's printed to the screen, sometimes we see the depreciated comments where it says, depreciated. And it'll tell you the name of the library. And then it comes back and says something like, this has been replaced by system.out or something, if we're lucky. Most of it doesn't do that. But this is how you would do it in your source code. And it would not necessarily dump a message out at runtime, because that's the runtime environment that's going to give us that error message. Instead, it would end up in the Java docs. The author, if you're going to document who wrote it, only one author name per author paragraph. So each author has to have its own different name. Version number, since denotes when the tagged entity was added to your system. And as an example of running it, if you have a graphics.java file, you would run java docs space graphics.java. And this would go through, and if you had tags, it would go through and find the tags, read the tags, and print the information to the screen. If you don't have any tags, it's not going to do anything. It won't even generate an error. Actually, it'll just say, okay, we're done. Won't do anything, yeah?
So all these are like automatically generated, because when you are writing a method or they are it doesn't generate automatically.
It won't generate automatically. What you're doing is you're adding the tags to the source code right before the method calls, or right before the class, at different parts of the program. You're putting in these tags and these comments. The tags can be used along with the comments. And you're writing all the documentation essentially yourself. It's not auto-generated. The HTML file is auto-generated. The comments, you have to write yourself. So as you're writing those comments and you're putting the tags in and you're using the commenting syntax, what Java docs is going to do is go through all that stuff that you wrote and put it all in this nice, beautiful looking HTML file.
So it creates a separate file.
It creates the HTML file. That's what Java docs does. It goes through, parses this out, looks for the tags and the comments, and creates a list. And it gives you that nice looking format that you see online. I love the format, that blue and white kind of hierarchy with all of the clickable levels that exist and all of the different things that you can do to navigate through the system. But unfortunately, I find that there's nothing there. I mean, it's a nice little navigation system, but there's rarely any comments there. But the interesting thing is that the comments are what you have to write in there. So if you're not going to write the comments, you create all that stuff. It'll document everything, but what are you documenting? So it's like garbage in, garbage out. You're not actually creating very much help in terms of a documentation if you don't write code.
Show me example like
Yeah, I believe I have an example coming up. Let me see one quick. Oh, no, I don't have one. Let me just take a brief moment here. See if I could find one on the internet, so I can see at least you can see what I'm talking about. If I go to Google, that was a good question. I probably, in the old days I used to have one, and then it got outdated. So I'm going to call Java doc example. Nah, what I want to see is a finished product. So here's a class description. Here's a Java doc here. Let me make this a little bigger. I'll follow through this. This might go to an example here where my class is documented here with a comment. We just saw that in the PowerPoint a few minutes ago, so this is not too bad actually. This method here, the field description is put in here. The constructor description is put in here, and you notice the syntax is all the same. We're not using tags yet. This example is just showing what I basically the basic comment, and then the tags. Actually, this is a pretty good example now. Now that I think about it, I don't know to give credit to whoever did this. Where did this come from, actually? Hold on one second. Let me just step back a few. This is from someone from CSU East Bay. Oh, cool. Looks like Billard. Of course, CSU East Bay. Good school. I also teach over there. It's kind of ironic I ran into his example, Billard. Dr. Billard. Okay, thank you for your example, Dr. Billard. Okay, so here we have class description. So we have JavaDoc, JavaDoc, JavaDoc. And then the tags themselves, we have author, version. These are some of the ones, actually we looked at all of these in terms of the tags that are available. And putting the tags in, here's an example. Description of my class. So before we had description, class description of my class, right here. We took that and we added some tags to it. This happened before my class. So it's going to show up as a comment that's going to be associated with the class, my class. And we're going to see the final. I believe he should have it down here at the bottom. I haven't looked at it yet. It'll be a mystery to me as well. But here's the tag. It says author John Doe, author Jane Doe, version number. So each one of them is a different tag. And it's simply followed by a space. So you put the tag in a space, and then the first and last name is this particular example. And looks like he didn't actually add any tags for anything else. So here's some tags here. Description of my method. Parameter A is a description of A. Parameter B is a description of B. But all this is white space, and you only need one space. However, this makes it a little bit more readable. I like what he did there. We're going to compile it now. In terms of the Java compilation, we can compile it and then we can run JavaDoc on it. And we're not going to see it, are we? Let's see. We can see the... You know what? Let's do it this way. Let's see. Let me run a little live experimentation. I'm going to bring it up in Eclipse. I'd like to see the JavaDocs. I believe there's a, I haven't, this is total experimentation because I haven't seen this. And I'm not one to do documentation, which I guess is sad. Think about it. So I'm going to go File, New, Java Project. Let me just set this up real quick. JavaDoc, example. Finish. Let's see if this works. I'm going to do File, New, Class. What am I going to call it? What was this one called? Well, my class. Okay. My class. Is it capital My class? Let's see. Yeah, it's capital My class. Okay. Okay, so let's run. Great. Let's see. Actually, you know what? Let's just go up here. Well, I don't have a main in here. Good deal. Hold on one second. Let me fix the code so I can make it runnable. Didn't include the right package. Again, get rid of that error, and I believe I'm missing a main. Let's just run a main in here. Actually, let me do this. You know what? Let's just do this. I might have to prepare one of these offline. Let's just see real quick here. Let's just copy this here. It's just that it may not do anything. There we go. Good. So I have a runnable code that doesn't really do anything. There's nothing in it, but it does compile. And there used to be, I can run it manually at the at a prompt, or there used to be something in here for Java docs. So let me just take a quick peek in here and see if I can find the. There was a menu option to generate the Java docs, but let me just see if I could find it. Nah, don't really see it actually.
I'm going to just create like the
HTML file.
Website Java site, like it gives the description for each class.
Yep.
In the same format and stuff.
Let me do it this way. Let's see. Let me try it using a slightly different approach here. I was going to see if I could find it in Eclipse. Let's see. Let me just save this. Save as. In here, I believe there's an option. I'm looking for it, but I can't find it. That generates the Java docs for you. It used to be down on the bottom, and this is a brand new. I recently upgraded, so I don't know exactly where. Let me just give it one more second. Let me just give it one more look through the menu just to be sure that I haven't been able to see it. No. No. Okay, so let's try plan B. If we compiles just fine. Here's the Eclipse extract. This is for 3.0 though. File export, select Java docs, and enter the path name. Let's see. Let's see. No, I don't think I have it in. This is a different version. This is not 3.0. Perhaps. Let's see what happens. Let's see what happens. Java doc example. Okay. Do you want to update Java docs location for Java docs example to the chosen destination folder or workspaces? Sure, why not? Doc. Let's do all. All right. So they moved the feature. It's in the export. And, okay, so I guess this was a worthwhile experimentation. Following the instructions that was on that website, which does work, by the way. I can give you the URL to that website so you can do this yourself if you'd like. I found it under the export. There used to be a generate Java doc menu option that went away. It looks like it's under the export menu now. Although I don't have 3.0, I have something else. The 3.0 option actually did work. It went through and generated, as you can probably see, it's going to be in my workspace directory. I'll go out and look at that in a few minutes. It's going to be in Java doc. I should see hopefully the HTML files for my class.html, package frame, summary, tree.html. I'm going to go out and look at those files in a few minutes, plus the CSS. And this is going to give us that blue and white looking Java doc, and actually I can probably find one of those quite easily. I was hoping that this guy would have had it out there, but he doesn't.
Creating for all the files in the project.
Yes, it created the Java doc for all of the files that were in the project. Let's see. Documents, workspaces. This one was called the Java doc example, and it should be in doc. Yep, here it is. So I found it after I generated it with Eclipse with the export feature. I found this is a great live experimentation. Found it in the doc directory. In the doc directory, what I'm looking at are all of the HTML files that I could potentially upload to a server and run from a server. If I run all classes Here we get all classes. It doesn't, here we go. This is what I was talking about. The lovely blue and white. This is what's being created automatically, and this is for my class. So this is the class, my class, that that Eclipse just generated for me. And then this is as I was saying before. Here's the description.
Like, you uploaded in that multi-map, those things.
You would upload it to your server, yes.
Yeah, actually, you also uploaded in that in assignments for those files for the multi-hash map.
Oh, I did? Okay.
Yeah, that is what
It could be, yes. I probably did upload it. And it's been years since I've actually worked with the Java docs, which is a nice good refresher for me. And my comment before is what I was saying was, here's that little notice, a description of, it depends on what you're putting in the code. And the problem that I see, and the reason why I don't really like using it requires me to document internally, and I'm terrible at that. This here's what was in the code under this comment, and this is maybe a good experiment. Actually, we had it up there. There we go. This comment was the description of A, description of B, description of, let's go back here for a second. Oops, lost it. Here it is. My int field, description of my int field. I didn't actually put anything in there. Description of my method, description of, and the constructor details, the field details, the method details, these are all of the documentation I put in here. Yeah, well, I copied and pasted and put in here. The parameter A, description of A, B, description of B, which is all directly coming from the code. Description of A, description of B, description of C. So you can see you're writing it. You're spending as much time writing it. You're just putting it in the source code. And then you're clicking a button, exporting it out as a Java doc, or running Java doc space the name of the file at a command prompt, and it will create it for you. So, well, that's interesting. So yeah, it does generate it. It doesn't generate an exe file, however. I am on a Mac system. Select Java doc and enter the path of it. Java doc. Oh, okay, well, no, I didn't need to do that because I already had. I have an upgraded version. It didn't require a path. It found it automatically because I have the Java bin directory in my path. I have a class path set, so that it didn't require that at all. So interesting. Like if you're familiar, if you want, there it is. I can zoom in if you want to write that down. If you want to experiment with it on your own. It's a CSU East Bay Billard. Looks like he uses it for his 3340 class. I'll leave that up here for a few minutes while I continue talking. So, just in case you're interested in finding out where that example was, I just did, as you saw, I just did a simple Google search and I found it. You can apply a template, which I didn't mention before, and you probably saw that in the, and maybe you saw it, I kind of went through it kind of quickly in the Eclipse options. You can apply a template to it, which will give you a different CSS. CSS is a cascading style sheet that's going to apply the color, the font size, the format specification. If you leave it at the default, you're going to get that blue and white looking screen. Some people like it. It's actually visually appealing. Only problem is, when I see that, I run away from it. Because in the past, every time I've gone, I've done a Google search and I've hit one of those things, there's nothing on there. It never provides me very much help. So that might just be on my own personal bias, but anyway, so that's what you needed to know about Java docs. You don't have to do it for any of the assignments for this course. However, as you can see, it's pretty nifty and relatively easy to figure out as well. So there we go. And just want to take a quick look here, so just to zoom in a little bit, I just want to check something about the format. So if I go export, which is what I did before, how I created this, because I kind of went through it a little bit fast before. I actually had to find it under Java doc that was under Java in terms of this object. And you may not have experimented with it, but you can automatically select compressed files for your project as well. Runnable jar files, create, it's sort of like an exe file, actually. I mean, it's just a runnable executable file. It includes the runtime support as well. I just wanted to see something here real quick, because I went through the options kind of fast. Use the standard doclet, standard template in the standard area. So use custom doclet. I'm not going to get into doclets, but I imagine that's where you're going to get the cascading style sheet information and all of the formatting that's going to be associated with it. So, oh yeah, okay. So, all right. So, anyway, that was a interesting experiment. Hopefully, it answered your questions. So back to the lecture.
I have a question.
Yes.
Can we, like, what is the version of JDK, like the one you are working on Eclipse?
Okay.
So how can I know from the Eclipse?
Let's take a look. Are you using Eclipse at all? It's the Helios version. Is what I've got.
What JDK it uses?
Ah,
version.
very good. Let's take a look. If I type in Java from a command prompt, I believe I updated this recently. It should tell me the version. And of course it doesn't. Let's see. I know there's a command. Does anyone know the command to get the version? Or is it up here? Oh, I know. I'm terrible at reading help as well. What is it? Version? Is it Java space version? Oh, how about that? What have I got here? This should work with all versions of Java. However, JavaDocs was supported right from the beginning. 64-bit. This is the runtime version. Let's see the Java C. Java C, I'm using 1.6.0_29. It's not the current version, I believe. It is JDK version. If I go to the Java website, ooh, a little big here. If we go here, and we go download Java JDK, I have 1.6, maybe it is current. Let's see. We should get some options up here. It should tell me L7. Let's see what this one is. It should tell me the version on the files. But this is going to be a different versioning number, maybe a different versioning number for a Mac OS X. 2.0, this is the same one. This is that's the wrong one. 7, I don't believe I've Solaris, Macs, Windows, Linux. I want to say this is not too old. I want to say that this is probably one version behind, and it's the Helios version of Eclipse. So if you have to once you install Java, let's just take a look at the SE here. You have to install Eclipse as well. Oh, SE update 29. What did I have? Oh, I have the most current version. I may have installed it fresh when I was demoing it at the beginning of the term. This appears to be up to date. So I would say it's 1.6 is the current, and then 0.29 is what I have installed. So this is the current version. And the Eclipse is what I was thinking might be old. I don't know. Actually, let me take a quick pick at the Eclipse versions to see. I may have download Eclipse. I believe that I probably updated everything at the beginning of the term when I was showing how to install Java. It is quite possible. I have the Helios version that works with the Android API, which is why I didn't upgrade that. I believe the earlier one, the later ones probably also support the API, but I'll find out next term when I teach the Android class. And I'll be updating that probably. I think either I lost my internet access or the URL's not good. No, Helios appears to be the most current as well, but let's see. I'm waiting for that link to come up. It's probably. Let's try this. Yeah, here we go. Indigo. Indigo is more current. Indigo packages. Eclipse is all by code name. And so yeah, I appear to be I definitely appear to be behind one version or so on my Helios. So, but and the interesting thing about Eclipse is most of the stuff has stayed the same, but the menus have really moved around a lot. So, I mean, as you know, as I mentioned before, actually, I probably went through here. Yeah, this is the Helios version. Anyway, as I mentioned before, the menu items might move around, so it might be a little interesting in terms of finding the options. Although the options are there, and Eclipse is nice because it supports more than just creating the Java docs. You can actually use it with what is it called? Mind blank. When you create the use cases, or excuse me, test cases, JUnit. It supports JUnit as well. So you click a menu option and you can create the JUnit templates for all of the different classes that you've created, and then you can fill in the details. So it automates the JUnit, does the Java docs for you, does the compilation for you. I believe there's something with it. It integrates the applet viewer, but don't quote me on that. The older version used to do that. So you could run applets and you could see them without having to actually load them on a website. So, all right, let's see. Seem to be in big mode. Let's go back down to small mode so I can see it. There we go. Garbage collection, our next order of business. Thank you for asking all those questions because it was interesting. I'm glad I did that.
Confused, like what version I'm using.
No. I hadn't taken a look at the documentation in such a long time. You know, it was nice for me to kind of refresh my memory on it as well. And, you can change the blue and the white too. You don't have to use the blue. That's the standard template. You can apply your own CSS to it as well. I didn't look at the CSS file, but it does automatically generate one as well. So you can definitely modify that. I believe this is where we left off. No, actually we didn't. There was one more slide left here. So we had the packages that are not defined. So one last thing about the package documentation. Unlike the doc comments, packages are not defined in the source code files themselves. So to generate the package comments, you're going to need to add a package.html file to the package directory. And then the contents of the package HTML between the body tags themselves will be read as if they were Java doc comments. So you actually have to create your own package documentation, put it in the body, put it in an HTML file, load it in the directory, and then the Java docs will read it and incorporate it right in with the rest of the stuff. It just won't read it from the source code. It reads it because there's no package information in the source code. And it won't go through the packages themselves, and there's no way of actually documenting a package in the same way that you would document the source code outside of creating this package.html file. They depreciated the author of the version. They're not used in the package comments. And the first sentence of the body is the summary of the package, which is used for the description. And any of the C's in the link tags must be use full qualified form for the entity's name. So you have to qualify the address and for the name of where it's going to be located, even if the classes are in the same package. So you have to put it in for everything because it doesn't know where to locate it otherwise. And you can also provide an overview of the comments for all of the source code files, placing the overview.html file in the parent directory. You know, I thought I saw a package. Let me just take a quick look here, actually. I thought I saw an overview as well as a... no, that's not what I want. I thought I saw an overview as well as a package. auto-generated package use, package summary, packages used, no, package tree. I didn't think I used any tree. I didn't use any packages. Package frame. This seems to be a little more updated versus the PowerPoint that's saying a generic package, but you would stick your generic package in here and it would read that file. These are ones that are going to be automatically produced. This is the help doc. Oh, there we go. Package interface enumerations. That looks like a generic help doc. No, it didn't automatically generate. I was looking to see, I was curious, I was looking to see if it was automatically generated, but it appears not. Let me just close these here so I don't get any problems with this. Just in case the internet goes down. Okay. No, I was basically curious. I was looking to see if what was generated, which we saw. We have some basic overview stuff that was generated, some package information, but we didn't include any packages, so it's all empty. So if you wanted to, you could create an overview and a package HTML file, stick it in the directory, and put a bunch of tags in there, and that would be included as well in terms of that particular information. So the contents between the body tags, opening and closing body tags, is going to be extracted out and used for the Java docs. And the comments is going to appear for the overview in the overview section, for the package in the package section. So, garbage collection happens on Tuesday nights. all the Java people, they roll the cans out to the end of the street. No, they don't do that. Instead, in the JVM, there's a garbage collector. He goes around all the little classes and picks up all of the empty, and they actually do call it garbage, believe it or not. What is garbage? It's pieces of memory that have been allocated but haven't been deallocated. So they're allocated, which means they're occupying memory space in the environment that's set for the program that's running. But nothing's accessing them. And the program that was using it has gone away. Or the class that's been using it has gone away. And so what the automatic garbage collection does is it sweeps through the memory. It takes a big broom through the memory and picks up all the pieces that don't have references to them and throws them away. Which is kind of interesting because if you know that's going to happen and it's out there, it hasn't been used in centuries, but then all of a sudden the class comes back to life and it looks for that, it just recreates it. So if it's not there, it'll recreate it, which means it'll take a little bit more time. It's a little slower in terms of the execution because you have to go out and reallocate the memory and repopulate it and redo steps that had already been performed. But in the meantime, the space is freed up. If you have a garbage collector, the reason why we're doing this is it frees up the memory, prevents a memory leak. Memory leak is when we've allocated all of the memory and we have nothing left. We've run out of memory because we can't use something that's already been allocated. In C or C++, we have the new and then we have the delete. The delete removes something that's been created with new. In Java, we have new, but we don't have delete. Instead, we have the JVM that does garbage collection for you automatically. And you can't tell the JVM to do garbage collection. It just does it automatically. So it's not something that, it's something to know about, but it's not something you have any control over. So objects are created using new, but there is no corresponding delete operation to reclaim the memory that's used by the object. So the Java virtual machine that's used garbage collection uses garbage collection as a concept to ensure that the reference objects will remain in the memory and to free up memory that's been deallocated but is no longer reachable from any references. So you could keep, in fact, in C++, you can create your own garbage collector using reference counters, using sweeping, scanning, and a bunch of other kind of similar techniques that basically just go through in the background and check each one of the spaces and say, is anybody accessing you? Is anybody accessing you? You can have a reference bit. When was the last time you were referenced? When was the last time you were used or changed? You could have accounting for references. How many things have reference to it? How many things haven't? So it depends on the technique that you would have to manually implement, but you don't have to do that in Java. It's done for you automatically. virtual machine uses the garbage collection itself. So it's collected without your intervention, but collecting garbage still takes place, whether you know it or not. So garbage collection is not guaranteed that memory will always be available for new objects. It solves many of the, but not all of, the allocation problems. So, but it does solve a lot of them. So if your program runs a little slow, it means, oh, it got garbage collected. Pieces maybe have gotten garbage collected. And so now the JVM has to go back and fix the problem. So they go back and reload classes that were loaded but now are unloaded or something. So that's one slide on garbage collection, because you don't really program with it. So there's nothing I can show you either. There's no garbage, it's invisible. Now we have nested classes and interfaces. We've seen classes, we've seen interfaces in previous lectures. This particular part is just putting the pieces together and nesting them inside of another. So putting one inside of another. So classes and interfaces can be declared inside of other classes and interfaces. So either as members or within blocks of the code, which means that one object that was created, say, talk about a class for a second, would belong to the other object. So this would be, if we were to rewrite the student and the teacher assignment, if you can think back, a long time ago, assignment number 2-ish, I think it was number 2, that did student and teacher objects, we could have created a nested interface, excuse me, a nested class where the teachers created student objects, and each one of the teachers owned or included inside of the teacher object there was 25 or 30 student objects, as an example. And they would be a member of, so it would be is a member of would hold true for the student. But in theory, they're separate objects. So in that particular case, the identity of a student is totally different from the identity of a teacher. We can assign students to teachers, but in theory, it's not really an applicable kind of example because of the is a member of kind of relationship. But if, for example, the teacher had an object that kept track of all of the students, that object would definitely be a member of the teacher object. Or the student object, if they had a separate object that kept track of the classes they were taking, it makes sense to nest it. So sometimes it makes sense conceptually to nest certain classes inside of other classes and interfaces inside of other interfaces, which is pretty much the same concept, except for using an interface instead of a class. Sometimes it makes sense, sometimes it doesn't make sense. So it's one of those things you kind of don't do in every program, but occasionally you want to know that it's available and that you can do it. So a nested class or an interface, which is declared as static. Static acts just like any other non-nested class or interface, except that its name and accessibility are defined by its enclosing type. So it's a class within a class. So it's defined by its scope. Static nested classes are members of their own enclosing type. They are their own type, although they are a class. They're inside of another class. They can access all of the members of the enclosing type, including the private ones, because they belong to the class. They're a member of the class. There is if you think of the is-a relationship, a nested class is a class of the base class, the outer class. So inside a class, a static nested class or interface can have its own private package, protected or private access, and while inside of an interface, all of the static nested classes and interfaces are implicitly public, because they're an interface, essentially. And they serve as a structural scoping mechanism for the logical related types. Static classes and interfaces themselves, the static nested classes. If a class is nested in an interface, taking a class and nesting it in the interface, it's always static. So it's omitted. We don't have to use the keyword static. It's just omitted by convention. You can put it in, actually. If you extend another class, implement any interface, and itself, it will be extended by any other class for which it is accessible. So it's accessible and extendable because it's part of the interface. And the static nested class serves as a mechanism for defining logically related types within a context which that type makes sense. Here's a bank account, and inside of the bank account we have a permissions. So this is like the student with a class list of students, as an example. This is a separate object that's inside of a teacher or a student. So outside, the code outside of the bank account class must be a bank account.permissions to refer to this class. So bank account.permissions, perm is equal to account.permissions for owner, as an example. Because it has to refer to the class bank account, permissions is inside of bank account. So the nesting holds true, which means an inner object is a member of the outer object. So you resolve the method of what you're running from a class level from the inside out. So we had to basically resolve the scope. So nested interfaces are always static, and since they don't provide an implementation, so interfaces themselves are static because they're interface classes that need to be implemented. They don't have you can't make an instance of an interface. So non-static classes, we have interclasses. So inner classes are associated with instances of its enclosed class. So bank account class action. And then we have deposit, withdrawal, kind of methods that are part of a bank account. And the action itself is a class inside of a class. So what we're looking at here is non-static classes. They're implemented classes. So when an inner class object is created, it must be associated with an object of its enclosing class. You can't create an instance of an interclass, a nested class that's inside of another class without creating the outer class, what that's saying. So if you create a bank account, you can't create an action without a bank account. It's the outer class that you make an instance of, and it includes an instance automatically of the inner class. Usually interclass objects are created inside instance methods and enclosed classes. When it occurs, the current enclosing object, this, is associated with the inner object by default. So it's this or that. So the last act is this.new action, deposit amount. So deposit creates an action object. A reference to the enclosing bank account object is automatically stored in the action object. So it's automatically done for you by and it's not called inheritance, it's called nesting. So by its nested interface, or its nested association. So using a save reference, the inner class object can refer to the enclosing objects fields directly by their names because they're a member of it, and the full name will be enclosed by the object this, preceding by the enclosing class name. So return bank account, this number, act, amount, all the different pieces of information. So any enclosing object that can be substituted by this. So it's referring to this object. And here's an example of it with the substitution of this.new action. And you don't have to worry about programming with inner classes or inner interfaces and nesting because you're not required to do any programming assignments that use that. In fact, rarely, maybe about 10-15% of the time, you probably ever nest a class or a nested interface. It only comes in handy when you want to modular, kind of create modules out of things. And here, a bank account with permissions. A bank account is the main object, and all these little sub-objects that are part of the main object. And it provides a nice level of abstraction. It's easier to see. Makes a cleaner class. It gives you the ability to I shouldn't say the word subclass, interclass, to create classes inside of classes, because they're really not considered subclasses. They're not sub-interfaces. They're members. There is a member of the outer object. So to continue on with the inner classes, the enclosing class can also access the private members of the inner class. The inner class can access the outer can access the inner, because they're all belonging. They're all private, but they're all belonging to the same private. And can only via an explicit reference to the inner class object. So you do have to reference back and forth. An object, actually just back. So it's the outer class referencing the inner class. The inner class already knows about the outer class. And an object of the enclosing class need not have any inner class objects associated with it, or it could have many different ones. So we don't have to have any, or we can have a lot of them. We can have more than one, I should say. An inner class acts as a top-level class, except that it can have static members, except for final fields. So Inner classes can also be extended, so it just adds more complexity to it. For inheritance, scoping, and hiding, information hiding, all members are declared with the enclosing class are said to be in the scope of the inside of the inner class. So they're all part of the same scope. And the inner class's own fields and methods can hide those of the enclosing object in a couple of different ways. One of the ways here is a member of the same name is declared in the inner class, then it overwrites it. So the inner class will be used instead of the outer class name. So you're overwriting it. Or a member with the same name is inherited by an inner class. So you do it through inheritance as well. So I'm going to actually kind of skip through this because we don't need it, unless somebody wants it. So looking at the expressions and you're all getting kind of overwhelmed or bored or something. I'll go through a little bit more, just to say that I did. Actually, no, I'm not going to do it. What I wanted to do is give you the concept of the inner class and the concept of the interface in terms of the nesting concept. But the particulars to how to do it, even if I go over the code for you, you don't have to do it. You're never going to. You don't have to do it for this particular class, so it's going to be totally lost on you anyway. It's just going to be boring information for you. But you can have an anonymous inner class where you don't have a name to it. You can nest inside of interfaces, and modifying the variables in an interface through the inner class can also be done. So it's lecture 10 if you want to download it and read through the slides to get the particulars for the implementation of the different concepts. But other than that, you don't need it until you start using it. You're not going to need it, and it doesn't make very much sense at this point to concentrate on the details. Questions, comments, concerns? Anything? So next week we have RMI, Java Beans, all those concepts. Servlets. It's going to be an overview of the Enterprise Edition, which is going to be the theme for the next Java course that I'm teaching. So it's going to be sort of the introduction, give you an overview, let you know if something you're interested in taking or not. So. But as for this class, we've actually covered all of the topics. So our final exam review will be in 2 weeks for those people who came in late. So next week is everything you ever wanted to know about the next class. And just basically capabilities, introduction to it. And then the following week will be the 7th of December, which is going to be the final exam review. The final exam is on the 14th of December. All of your assignments are due on the 12th of December. So I should hope that you're working on them. So, and they get uploaded into the LMS. So questions about the rest of the course, which is winding down quickly? No? Questions about the assignments? You don't have to do, did I strip out the last one? Let's see, let me take a look. Let me revisit the assignments. So I can remember what I said. Object-oriented programming in Java. I believe I cut the last one, didn't I?
Yes.
I think I did. We have a midterm, we have a CSLO. Here is it, course materials. Yeah, you don't have to do the applet. No applet code for you. If you haven't found them already, there's nice little how-to videos on the assignments in here that practically give it away for you. Hash map might be the more challenging one. Come close and do something for it, and I'll be generous with the scoring.
So, like, I have a question.
Yes,
Does it take null values, the hash map?
it could.
Because I was trying them, like, I just put 1, 2, 3, and then by default, actually, it is taking about 10 values,
Mm-hmm.
and it's already putting the nulls for the rest of the ones.
It will probably do that by default, because it's probably, if you set the code to have it initialized to null and there's no variable provided for that particular spot in the tree, then it will be set to null.
So if we don't initialize it, then what is going to happen?
You'll probably end up with an error message.
So, but like the
'Cause it won't be able to
again
build-
You are trying to put the null over null. You are again inserting a null value.
Oh,
Third value. So it is again putting over the null value.
that which should not cause a problem.
Then when you are returning like all at the time, it's the string is not taking null. sort of I'm getting the error in that part.
It's not taking the nulls as in the string?
It is not recognizing null. It is recognizing it as a null. It is
Okay.
not as part of that one, as a value that we have passed. Like 1, 2, and then null.
I'd put it in your loop so that if the value is null, ignore it. And only print out the ones that aren't set to null.
Oh.
That way it will, because I can see where a null is not going to be sent to the string class correctly. Because it's empty. There's no string. Or set it to an empty string at the beginning of it. If it's null, set it to, empty. Use the string. If you're assigning a string that's being printed out.
So instead of passing the null value, just pass the empty string.
Yeah, you could do that. The interesting thing is probably the hardest assignment in the course, and it's hard because you're following somebody else's, and there's a pre-built class that you're working with that is, I want to say, kind of on the old side as well. So depending upon your version of Java, you might get some depreciation errors with it as well. But, warning messages are not going to be errors. So hack at it, do what you can. I'm going to be very generous with the grading on this one here. The rest of them should not have any problem at all. In fact, when I redo this course, I'm going to take this one out. I'm also going to take out the applet and replace this one with something else next time. But so this will be the last time this one's in here, but because it's problematic. But so next time we'll see something else. But it's only worth, I think, 5 points, right?
Can you give some programming essays? Can you suggest any for us?
Can't really. Well, outside of the Deedle and Deedle text, did I give that to you probably at the beginning of the term? I have internet access today, so I will look it up. Deedle and Deedle. Detail. D-I-E-T-E-L. And Deedle. He's got about, I don't know, I thought there was 8. He's up to version 7. You can find some of the earlier ones here for $7.12. There's 59 of them that are used on Amazon. No excuses for not being able to afford a textbook. I would get some of the later versions, though, maybe version 6. This is the 6th edition. I think the 7th or 8th might be the current right now. Actually, if you go to the Deedle website, I could probably find that. I don't know if there's a link to the website. Let's see. Maybe this link will take me there. Oh, Android for programmers. Look at that. Now, Deedle is my recommendation. Here's the 7th edition. 7th, I believe, might be the. I'm looking for the year. Do we see the year of publication on here? No. Given that the price is a bit higher, I'd say 6th edition is your bet. If you go back too far, you're going to go into a different JDK version.
Yeah.
And you're going to have different libraries. Slightly different. Not a big deal. The concepts are the same. It's just some of the libraries, especially for the I/O. Stream. The stream stuff has been updated. So you want the 6th or the 7th edition. But the 7th edition still looks pretty pricey, so I want to say that's probably the more current. But you could do your research. This is the only book I recommend. I do not recommend any other book. If you don't get this book, use the internet. The internet's a great source of information as well. Oh, we have the 8th edition. No program with the 8th. There is an 8th edition, so maybe you can find a 7th a little cheaper. So, series page. This looks like the website. He actually also has some pretty good. I haven't not experienced his C++ books, only his Java books.
I was asking about Java.
Huh?
I was asking about Java.
Yeah, I know. This is Java. This is the Java one. I was curious, so seeing, he's got C# in here too now, Visual Basic. And the Visual Basic one was okay. I've seen that one. But the Java one, I think that's his best book, How to Program in Java. Any other really excellent questions? That was a good question. We have some good questions today. No, then I guess we're done for today. So enjoy your Thanksgiving. Stop the video.